Okay, great. So let's start. So first of all, welcome everybody to this second part of the webinar that we are having on the topic of AI plus semiconductors. We are once again joined by Mr. Pradeep, whom we had introduced last time. He's a luminary in this field, and after doing some spectacular work in US and then starting his own startup, he's been here and is really passionate to bring this combination of two extremely hot happening and also futuristic topics. One is semiconductors, another is artificial intelligence. And as we know that there are a couple of people in semiconductors, there are a couple of people in AI, but there are almost, you could count on the fingers of your hand the number of people who are combining AI and semiconductors, which Mr. Pradeep here is doing through a very fantastic initiative. And today we are really here to hear from him. What is this combination that we are looking at and how does this pan out? So over to you, Mr. Pradeep, for your sharing that you want to do on how these things combine and what is it for students and working professionals ahead.
Super. Thanks a lot, Santosh, for this opportunity. As we discussed last time, right? The world is changing. There's a lot of stuff that is happening on the AI world, and more importantly, from the semiconductors perspective, right? Not only from a technological progress perspective, but also from the geopolitical perspective, there's a lot that is happening. There's a lot of investment that is going into semiconductors, be it in manufacturing, be it in design, be it in developing new process nodes, R&D, the lithography, right? There are countries that are geopolitically dominating the space. So it is very important for us to understand not only from a tech perspective, but also from a nation's perspective, why semiconductors is important and how AI is going to change the way the world will look upon countries, right? If you are good in semiconductors, if you are good in AI, if you are good in space, there's a lot of power that the country will start commanding. So from that perspective, I would strongly urge the students to start enhancing their core expertise in whatever domain that they are studying, be it civil engineering, be it aeronautical engineering, be it computer science, be it semiconductors. Go deep down into the domain. That is important, as well as enhance their skills with artificial intelligence and converge AI with the core domains. So with that as the context, right? Since our focus is on semiconductors, I will be happy to share a presentation with you today. This is a technical presentation targeted towards electronics and computer science students from both the streams I meant, and how we can converge artificial intelligence in the semiconductor domain. So let me share my screen and then I'll walk you through the slides. As I mentioned, it's going to be technical, so please excuse me if it is flying over your head, but it's important to understand because this is what the world will move towards. With that context, let me share my screen. Can you see my desktop?
Yes, we can see the PPT.
Awesome. Yeah. So okay. So I'll first introduce myself, my company, right, and the team. So this whole webinar is targeted towards electrical engineering and artificial intelligence for electrical engineering. Electrical engineering basically encompasses semiconductors, could be core electrical domain like power machines, so on and so forth. But we'll focus on IC design for today. Okay. So quickly to introduce you to the team, right? So I basically have founded this company. I come with 20 plus years experience in companies like Intel, Texas Instruments, Cypress Semiconductor, and in my previous startup, which I co-founded, uh, I was basically managing the product and tech development from AI applications perspective. Rajesh is a senior member who comes with 25 plus years experience in software and software architecture. And Ravikant actually was my colleague at Intel. He's now heading product design and the business management part of things. Okay, so we are part of various global entities. We are part of Alchemist, actually alumni of Alchemist Accelerator in the Bay Area. We are now with Canadian Innovation Factory here in Toronto. And I've had multiple collaborations with Intel, Microsoft, NVIDIA, and we were part of NASCOM Center of Excellence for AI and Data Science. Okay, so that's our brief background. So let me start into the technical aspects of the presentation. But even before I get into the technical aspects, I thought we will actually make it a little more interesting, starting with the fundamental question, right? What is design? So all the students want to basically become designers, right? It be it circuit designers or software designers, so on and so forth. But what is design, right? System design. Okay, what is design? So fundamentally, right? Given an environment, identifying the parameters that control the environment and choosing the right settings of those parameters to steer the environment towards a required target or a defined specification. That is, in my opinion, is design. This is a loaded statement. It's a heavy statement. So you may not get the gist of it in the first read, but I'll try to make it simple for you, right? Imagine you are playing a video game. Everybody loves to own a PlayStation or an Xbox and wants to play games on that, right? So you're basically playing a Need for Speed or a car racing game. Okay, so what is design? What is the context here, right? Now you have an environment here. So you have a game like Need for Speed. Okay, you have your console or controller where you are pressing the buttons, which basically means you are taking a certain action, right? And then you are looking at the screen, you are observing the state of your car, the speed of your car, the direction in which it is going, right? What are the obstacles in front of it? Are you on the right lane? So on and so forth. Those are the observations. And at the top right corner of your screen, you will see the score, right? It's continuously increasing or reducing. Your power is increasing or reducing, so on and so forth. Now, there are three things that are happening here. You are taking an action, you are observing the state of your environment, and then you are also looking at the rewards. And you are trying to enhance your rewards through actions and with observations, right? This is basically what you are doing while playing the brain. Your brain is working so fast that you're not really conscious about the fact that you're actually observing the state of the system or the environment, the rewards that you are getting, and the actions that you are taking. It is happening in a reflex mode. Your brain is used to this. It's working in a reflex mode. But essentially, this is what design means. It basically means that while playing a video game, you are indulging in design by continuously optimizing your rewards, right? understand the statement that you are trying to optimize the rewards. You are trying to get the best possible rewards in this particular game. So I'll repeat it. While playing a video game, you're indulging in design. Your brain is optimizing continuously to maximize the points. Okay. Now, what does it mean in terms of AI? And this is happening as we speak. The same environment, the same set of actions, observations, and rewards exist, right? But instead of you playing, now there are AI agents that can play this game. They can do a better job than you because they work at a much greater speed, right? The instructions that the AI agent can execute happens in gigahertz scale. Obviously, the power consumption and all those things are not as good as the human brain is, but still, AI agents can actually do or replace you in playing this game. They can take actions, they can observe the state of the environment or the system and try to maximize the rewards, right? That is how AI is being applied to video games. Okay. Now, why am I talking about this? Instead of a video game in the same setup, I can actually do circuit design. I can replace the Need for Speed game with a circuit simulator. So here my environment is now a semiconductor circuit or an electronics circuit, right? I have an AI agent that can take actions in terms of designing the parameters that control the performance of the circuit by observing the state of the circuit, say the bias point or the gain of the circuit or bandwidth of the circuit, right? So there are multiple electrical engineering properties that this circuit would have. Those are the observations. And basically, while changing the design parameters of the circuit, we observe, or the AI agent observes the state of the circuit and is trying to achieve a desired specification, right? Imagine there is a specification that, okay, this particular circuit has to be having a bias point of 0.75 volts, right? But when it starts at 0.4 volts, there is a difference of 0.35 volts between the targeted specification of 0.75 and the current state of observation, which is 0.4. So you can define a reward as minus 0.35, the difference between the target versus what is the current state of the system. Okay. The whole idea here is while playing a video game, you were indulging in design, then you have replaced an AI agent with yourself to play that game, and now you can actually replace the video game itself with a circuit environment and indulge and make the AI agent indulge in design. And this is not limited to semiconductors. You can have a environment from any engineering domain, right? But the concept of how an environment is acted upon by actions and the state of the system and the rewards that it gives out, which the AI agent absorbs, is what the world is going to move towards. For that matter, it is happening. For example, ChatGPT, right? It works on a very similar concept. So if you search about reinforcement learning for ChatGPT, you will find a picture like this. Okay, now extending this and going more deeper into AI agents for circuit design. So I'll do a small demonstration of how we have built artificial intelligence agents for circuit design. Right. So many of the students would have learned about inverters in their fourth or fifth, or I don't know which semester they would have studied, but they would have definitely studied transistor based design, and more specifically MOSFET based circuit design, right? So this is a standard topology of an inverter. The reason I've connected the output to input is basically for self-biasing. Don't worry about that at this point in time. But look at this as a standard inverter. You would have a SPICE netlist, right? When you are running your simulations, when the student runs his or her simulations, they basically draw the schematic and then invoke a simulator, say in a cadence environment like ICFB, Analog Artist, ADE, right? Where the netlist is generated and the simulation is run to observe the state of the system, or a particular design parameter is achieved. So that is typically how a circuit is drawn and simulation is performed. Now, what we have done is basically added an AI agent. While you do your work in the standard ICFP cadence environment, right? The idea here is to basically interact with this environment, okay? Read the operating points of the circuit and control the device sizes. So here you can see PW and NW as the parameters of this particular circuit. You can control the device sizes to modulate the output voltage here. So what do I mean by this? Just understand the setup that you have a typical environment to run your simulations and an AI agent which controls these simulations. Okay. So if the students can recollect, so this is the transfer characteristic of the inverter circuit, where your input voltage as it moves from 0 to 1, your output voltage falls from 1 to 0. Standard inverter specification, characteristic. Now, here is the fun part, right? Imagine you want your inverter characteristic to pass through this red point. Okay, this red point is basically the bias point or the switching point for the inverter. Based on the size of the inverter, meaning the NW, which is NMOS width, and PW, which is the PMOS width, your inverter characteristic changes. As a designer, you have the knowledge and the skill to size these devices to make the transfer characteristic, this blue line, pass through the desired specification bias point, that is the red point, right? You would do it. But now what we are doing here is making the AI agent learn by itself and make the inverter characteristic pass through the red point. So this is the initial phase of learning, where the AI is trying to figure out, as you can observe here, right? These numbers, as they change, the characteristic is moving to the right or left, right? It is trying to learn. This is the initial phase of the AI agent learning. It is basically playing with the system, trying to understand as it changes the design parameters, which is the NW and PW, what is happening to the inverter characteristic, and observing what actions it should take to make the blue line, which is the transfer characteristic, pass through the red point, which is the desired target specification, right? Now on the right side, I have a learned system where you can observe that if the red point, which is your bias point, is to the right of the chart, right? It increases the PMOS width while decreasing the NMOS width. And while the red point is to the left, it has figured out that it has to increase the NMOS width and decrease the PMOS width. This is how you as a designer would actually design. Now, instead of you designing, it is the AI agent that is designing this particular inverter for you, right? It has learned that if the PMOS width increases, the transfer characteristic moves to the right. And if the NMOS width increases, the transfer characteristic moves to the left. This is how an AI agent has learned how to design a inverter. Okay, we'll make it a little more complex. So I have taken a more complex circuit like a voltage to current converter. I'm not sure if the students have actually studied this, but I would strongly recommend that they understand this, because this is one of the most important circuits in electronics, IC design, right? Here we have a closed loop system. We have an operational amplifier, which I'm pretty sure the students would have studied, right? We have a pass transistor, a current sink sort of a thing, and then we have a resistor. Okay, so as the voltage here, Vref increases, this is a closed loop system, so V out has to follow Vref. Right. The reason I said this is an important circuit for students to know about is because it is a closed loop system. The students would have to not only know how to design the circuit, but they also have to understand the feedback concepts, right? So in this particular case, Vref will be, so Vout will be equal to Vref by modulating the Vamp voltage, and the current that flows through this particular device would be Vout by R external, right? So this is the standard voltage to current or a LDO circuit, right? And there are more advanced versions of this, obviously. But the point I'm trying to make here is, if we take a complex circuit like this, and then you again draw the circuit in your ICFP cadence environment, and then run your analog artist or ADE simulation, you basically can perform a DC level simulation to understand how this whole circuit is performing, right? What is the offset, so on and so forth. I'll explain the concept of offset in the next slide. Now, what we are trying to do here is we are building an AI agent that can trigger simulations, understand what are the operating points in which the circuit is functioning, and start controlling the device sizes to achieve the target specification. So let me go to the next slide. Okay, similar to the inverter optimization demo, here you can see that, okay, the orange line is my target, which is my input is equal to output. It is a slope of one line, right? M equals one line. So the orange line is my target, whereas the blue line is my simulation output. Okay. So here you can see that one more thing I wanted to explain was, we are controlling the way we controlled NW and PW in the inverter, right? Here we are actually controlling 6 different parameters in this circuit, right? So 1, 2, 3, 4, 5, 6. And then there's one more parameter, which is this device size, to basically ensure that V out is equal to Vref with the least possible offset being the difference between V out and Vref, right? So here, if the orange line is our required specification with offset is equal to 0, the blue line is what we are observing, or the AI agent is observing, which shows that there is an offset between V out and Vref. As the device parameters are changing, this particular line, meaning the offset, is changing. Okay, and the intent is to make this blue line fall on the orange line. So through a process of learning, eventually the system figures out, the AI agent figures out that it has to change the gain of the system to make the offset equal on the right and left to, and this is not exactly ideal, but even if you were to design this circuit, this is the characteristic, the one on the right side, right? This is what you will achieve as a designer, where you will figure out that you cannot have zero offset, meaning the difference between V out and V ref cannot be zero between 300 millivolts and 500 millivolts, which is the DC simulation that we have performed. Okay, so but the point to understand is that the AI agent is able to figure out, like a regular designer, that it has to change the gain of the system to make the offset near zero across 300 to 500 millivolts. Okay, so what does that mean? I mean, all this is good. So I have explained about how AI can be used for IC design. I demonstrated two circuits, right, which proves the concept. But what does it mean for you as a student, right? What does it mean for even professional circuit designers with 5 years, 10 years, 15 years experience? What does it mean? So the future of jobs is going to change. You may not see it immediately, but mark my words, it is changing. It is going to change. It is going to change in a big way. Companies like Cadence, Synopsys, even semiconductor companies like Intel, Texas Instruments, right, Qualcomm, all these companies are investing billions and billions of dollars either into designing AI chips or enhancing processes, design methodologies of circuit design using AI. So in one part, you have AI chips being designed. On the other side, you have AI actually being utilized for chip design, AI being utilized for enhancing design methodologies, design processes. So both the things are happening, and there's a lot of investment, literally in the tune of billions of dollars, that is being invested into this. Okay, but there are hardly very few people in the world who actually know both the domains and can converge, right? Now that is where it is important for students to understand that there is domain knowledge that is required. There are design requirements that are to be understood in that particular domain, and the students should have the ability to translate domain and design requirements to AI specifications. If you have the skill, you are a hot commodity in the market, right? If you can go to an interview and actually tell the interviewer that you have the ability to translate a domain and design requirement to an AI spec, you're good in core domain, you're decent in translating domain and design requirement to AI spec, right? 99% of the time, the interviewer may not actually know this on how to translate domain and design requirement to an AI spec, but you are a good asset to the team. You are a good asset to the company. That is something that I would say at this point in time, in terms of the future of jobs is going to evolve. So coming back to what we discussed, right, in our context with respect to semiconductors and circuit design. So you as a electronics and communications engineer, right, you would have knowledge in circuit design requirements. It could be various requirements like voltage gain, impedance gain, frequency, phase margins, right, offset, noise, so on and so forth. And then you have the design parameters, which is like at the device level, the drain conductance, drain current, or the transconductance, bias currents, device sizes, RLCs, so on and so forth, right? While you as a circuit designer have to know this, it is necessary to understand this. Then there is the AI side of it, which a computer science student would know. All right. A CS guy would basically understand AI or and reinforcement learning parameters such as hyperparameters, hidden layers, cost functions. Right. These are the things that basically a computer science student would know. Right. Now, this is where things become interesting. While the ECE student understands or has to understand circuit design requirements and circuit design parameters, you have the computer science student understanding the AI and RL parameters, right? The ECE and CSE students have to collaborate. Both of them have to exchange information in the language of the other and collaborate, right? Connect the dots and build a system like the one that I've just shown you, where you have a circuit simulator, a circuit talking to an AI agent. Okay. Do the EC guys have to know how to build AI RL networks? You are not required to know them at this point in time, but you have to start learning about them, right? You don't have to be an expert, but at least you have to understand the language. You should have the ability to translate circuit design parameters into AI parameters. Simultaneously, should the computer science and engineering student know about circuit design? No, you don't have to, but you should at least understand what these terms mean, what the domain parlance, right? 95% of the time you will spend on the AIR RL side of things, but in any domain where you will build these AI engines, these reinforcement learning modules, you are expected to at least have some knowledge of the domain in which you are going to apply AI or RL. The problem today in the world is everybody talks about AI or RL in a silo, right? But understanding the domain in which this is applied is pretty important. That is when you can build a good system. Okay, so final conclusion, right? How do you add value to your own career? Right, as a student, at the end of the day, you are looking for a job, all right? You have to build a career. Don't look at this as a job, right? As I mentioned, the world is changing. The investments that you make today will help you in defining your career, right? It is not about getting the first job and then work uh, in the same job for the next 30 years. Those days have gone, right? If you get into a job, the expectation is that you continuously learn and deliver at the same time. And what is it that you want to learn? You have to learn your core domain subjects. You have to as well learn the futuristic technologies like AI and reinforcement learning, right? So just to summarize, I know there are a lot of points here, right? But I will start with the high level summary. What does it mean with respect to your job or the jobs, right? AI and specifically RL, which is reinforcement learning, is set to enhance efficiency, reduce errors, and speed up the design process in the semiconductor industry. Right? It is happening as we speak. So if you were to learn AI, IC design with AI, you are going to be a hot property in the market, in the job market, right? And the reason I say this is because there is a lot of demand for advanced semiconductors. It is increasing. It's a $661 billion market. I mean, the global semiconductor revenue is expected to reach $661 billion in 2024. India is emerging as a key player in this with significant governmental investments. And this expansion of the semiconductor industry underscores the need for skilled professionals AI is likely to automate routine and repetitive tasks, and the shift will require professionals to have both engineering expertise and skills in AI and machine learning. Job roles will expand to include AI specialized positions, right? And reinforcement learning basically fosters the creation of more intelligent, adaptive, and responsive AI systems. So if I were to put all these points together, I will conclude with this summary that AI and RL are set to enhance the semiconductor industry. So it's good to be prepared. Yeah. Thank you. Would love to take any questions if there are, or you can shoot me an email and I'll be happy to respond back. Yeah, that's it, Santosh, from my side.
Thank you, Pradeep. It was wonderful knowing a lot of, you gave us a lot of insights on how reinforcement learning and circuit design could go hand in hand. And it's also opening doors to the new set of job roles and career options for the students. People on the audience, if you have any questions for Mr. Pradeep.
Hello, sir.
Hello. Yeah.
Yes. How can students and professionals stay up to date with the latest advancements and trends in the integration of AI and reinforcement learning in IC design or related fields?
Sure. So, good question. There are two parts to this, right? One, if it's with respect to students, first, they have to be good in circuit design. There is, you cannot cut short that, right? You have to have good fundamentals in your core domain, which is circuit design here, right? Now, that is one thing. Now, coming to your specific question, how to be up to date, right? I'll tell you my way of doing it. I read a lot of tech papers. So there's a lot that is happening in the AI world. Okay. There are very few papers that have been published or that are being published in terms of how AI can be used for circuit design, right? But there are a lot of papers, almost you can imagine 10 papers that get published every single day, right? You don't have to obviously read all the 10 papers, but focusing on a core paper in reinforcement learning, right? Read the RL paper or AI paper separately and figure out how you can apply that to circuit design. So this is a more advanced method of staying up to date, but I don't think it can happen on day one. It will take some time before the student reaches that stage of understanding an AI RL paper and figuring it out to apply in circuits. What we have done is we have made the life simple for students or professionals to actually use our platform where we have AI engines running in our platform. As a user, be it a student or a professional, should be able to upload their circuit schematic into our platform and then select an AI engine to optimize it. So we have actually reduced the barrier of entry for students or professionals to start using AI for circuit design. So you design your circuit in an open source environment like LT Spice, upload your circuit schematic, and then choose an AI engine to optimize your circuit. So we have actually made it very, very simple for users such as students or professionals to utilize AI for circuits. So that's a starting point here.
Just one quick thing from my side, since Mr. Pradeep mentioned about papers, which is this is especially for students. Be part of the IEEE student bodies or student chapters which are there in your college. I'm seeing Dr. Prashanta here on on our list. He's a very accomplished professor. And in Atria, we have IEEE student bodies, and Dr. Prashanta has recently set up one of the student bodies. So to all the students out there who are listening to this and will listen in the future, be part of your IEEE student chapters. There are a lot of papers you can access there. There's a lot of good work which you can access over there. Over to you, Ranjani.
Sorry, he had
Yes.
another question. Yeah,
Pradeep, it was very good presentation.
thank you. Yeah.
Yeah, there are two components here. One is knowing the circuit concept, and other
Yes.
is knowing the artificial intelligence and machine learning concept. Now, that means essentially it need to have two components. One is electronic side, and other is computer science side. Okay,
That
how
is
to
correct.
interface these two components? Generally, the students who are very good in electrical or electronic concept, they don't have interest in AI and ML. The students who are very good in AI and ML, they don't have interest in circuit concept. How to bridge the gap between the two?
Excellent question, and that is where we come into the picture. So my startup company actually has built this web-based interface where if you are an electrical engineering student or an electronic student, you will focus only on circuit design and you upload your circuits. Think of this as the left side of the system, right? On the right side of the system, if you are a computer science student who is interested only in AI or RL, right? You build AI RL agents, okay? So you focus only on reinforcement learning or artificial intelligence, right? We have built IP, we have built the interface where when a circuit designer uploads his circuit, we translate that into a language that an AI agent can understand. The computer science student can focus only on building an AI agent based on the requirements, and then he designs the AI agent accordingly. On our platform, this electrical engineering student can see his circuit getting optimized using the AI agent that a computer science student has built. So we have built this platform which integrates circuits with agents. So you do not have to know both of them. You just have to know what you are working on, and we will manage the rest.
That means the
Just
suggestion
quickly-
to have a model of combination of both. A student
Yes.
team comprising of electronic student and computer science student working together.
Yes. Yes. So you would basically learn how to use AI for your circuits without actually learning about AI if you're an electronic student. If you're a CS student, you will learn how to build AI agents without understanding semiconductors, right? So if you remember, I quoted you have to be good at your core subject, like 95% of the time you will be focusing on your core subject, right? But just 5%, and that is where we will help you in figuring out whether the translation is happening correctly. So if I take, say, operational amplifier voltage gain, right? I have that as a circuit level specification that I will translate it into a AI specification. So if you just double check, okay, it has translated correctly or the number is showing up correctly, that's enough. And that doesn't require a high skill to do that. Yeah.
One more last question.
Sure, please.
What made you to take the example of reinforcement learning other than supervised than supervised learning? Because of
Excellent
closed loop-
question. Yeah.
closed loop control system you want to demonstrate?
Yes, right. If in one of the statements that I had made, right, reinforcement learning basically fosters the creation of adaptive and responsive AI systems. In supervised learning, you are basically relying on prior data. That is also a challenge, right? How much of data will you have for your circuit? There's only so much of data that you would have a priori to optimize your circuit, right? But reinforcement learning, it is triggering simulations, understanding it in real time, understanding the observation space and the rewards, right? And is accordingly able to fine tune the parameters. That's the beauty of RL. It's in a control system loop, right? And this is also something that I would strongly urge the student community to focus on, is control systems. This is, I'm sure, part of electronics students' curriculum, right? They would have studied it, but they would not have understood the importance of control systems, like a gain margin, phase
10 years
margin.
back, that course was there for all branches, including mechanical and student also learning control system. Earlier.
It's coming back. It's coming
Yeah.
back. Even computer science students have to understand computer control systems, in my opinion, because the entire concept of AI is a control system loop.
Exactly. Yeah.
Yeah.
Thank you.
Sure.
Just quickly to Dr. Prashanta's point, this was the first question I asked Mr. Pradeep also, that why not supervised learning instead of reinforcement learning? And his Mr. Pradeep's question answer totally convinces me. Just one more thing, Dr. Prashanta, your question about how do these two different students come together? As you know, Atria is all about multidisciplinary learning and training, and which is why via Atria Education there are two platforms that we are trying to evolve. The first platform is post your graduation, you can take certification training from Atria Education, where with Mr. Pradeep, we have now this almost 3-month plus program where both these kind of students can come together and then they are taken to a pathway through the groups to learn this. We are also looking at another platform where we are collaborating with engineering colleges to say, can your 6th sem students, EC and CS who are otherwise separate, can they now start coming in through the pathways? And Mr. Pradeep has already now given us the prerequisites which are required. So yes, your question is amazing, and hopefully other colleges will adopt now this mechanism that we are giving to them, where you can combine these two and have a multidisciplinary approach to it. So just on that part. Over to you, Ranjini.
Thank you. Thank you so much for the wonderful questions, Dr. Prashanta. And you almost kind of opened the doors for the future generation engineers who would look forward to this program hosted by A2 Education, along with Mr. Pradeep. And there is a lot of scope, and this sort of courses are defining and redefining or recreating new spaces and job roles for the future engineers, is what I would like to say here. And thank you, Pradeep. Thank you,
Thank you.
Santosh, for hosting this two-part webinar series, which we started off with Mr. Pradeep last week. So, audience, I would like to say stay tuned for our upcoming webinars on semiconductors and furthermore. So, thank you all.
And also do check out our YouTube channel, so that where you will keep getting all these webinars and informative, because like Mr. Pradeep started off by saying, and yeah, first of all, thank you so much again, Mr. Pradeep, for taking your time out and sharing your wisdom. To the students who are out there, this is almost 20 years of wisdom and continuous learning, which he has been applying, which you have just got in a burst of 45 minutes. So really thankful to Mr. Pradeep for that. And to the students and the working professionals who are out there, do check out the YouTube channel of Atria Education, because you will get a lot of these informative inputs to you. And like Mr. Pradeep was saying, there's a lot of stuff which is out there. But in a world where credibility is increasingly becoming a question mark, you need to really listen from people like him to know, okay, this is the fact and this is where I need to go behind. So thanks so much. And thank you to everybody.
Thank you. My pleasure. Thank you.
Thank you. Bye-bye. Thank you.
Bye.